Welcome to Course 1 of Thermodynamics. The name thermodynamics stems from the Greek words therm, heat, and dynamos, power, that means convert heat into power. Thermodynamics can be defined as the science of energy. Energy can be viewed as the ability to cause changes. Thermodynamics depends mainly on two laws. First law is simply an expression of the conservation of energy principle, and it asserts that energy is a thermodynamic property. Second law asserts that energy has quality as well as quantity. And actual processes occur in the direction of decreasing quality of energy, increasing entropy. There are two statements for the second law of thermodynamics. Kelvin-Planck statement. It is impossible for any device that operates on a cycle to receive heat from a single reservoir and produce a net amount of work. Clausius statement. It is impossible to construct a device that operates in a cycle and produces no effect other than the transfer of heat from a lower temperature body to a higher temperature body. There are two thermodynamic approaches: macroscopic approach and microscopic approach. Macroscopic approach is known as a classical thermodynamics. It is the study of thermodynamics that does not require a knowledge of the behavior of individual particles. Microscopic approach is known as a statistical thermodynamics. It is based on the average behavior of large groups of individual particles. Dimensions and units. Physical quantities are characterized by dimensions such as length, velocity, temperature. The magnitude of the dimensions are called units. Basic dimensions are called primary or fundamental dimensions, for example, mass, m, length, L, time, t, temperature, T. Secondary dimensions are expressed in terms of the primary dimensions, for example, volume, v, velocity, v, energy, E. There are two systems of units: the English system, which is also known as the United States customary system, and the metric SI, which is also known as the international system. Examples of dimensions and units. Force that equals the mass multiplied by acceleration. The unit is Newton. Weight that equals mass multiplied by gravitational acceleration. The unit is Newton. Work that equals force multiplied by displacement. The unit is joule. Density that equals mass divided by volume. The unit is kilogram per cubic meter. Specific volume that equals volume per unit mass. The unit is cubic meter per kilogram. Specific weight that equals density multiplied by gravitational acceleration. The unit is Newton per cubic meter. Specific gravity that equals the density of fluid multiplied by the density of water. It is unitless dimension. Systems and control volumes. System is a region chosen for study. Surrounding is a region outside the system. Boundary is a real or imaginary surface that separates the system from its surroundings. Closed system versus open system. In closed system, mass cannot cross the boundaries. Energy can cross the boundaries, heat and work. It is known as control mass system. In open system, mass and energy can cross the boundaries. Boundary is known as control surface. It is control volume system. If the energy does not cross the boundaries of the closed system, it is known as isolated system. Properties of a system. Properties can be intensive or extensive. Intensive properties are independent of the mass of a system, such as temperature, pressure and density. Extensive properties whose values depend on the size or extent of the system, such as total mass, total volume and total momentum. Extensive properties per unit mass are called specific properties. State. If a system is not undergoing any change, at a point, all properties can be measured throughout the system. These properties can be used to describe the condition or the state of the system. If the value of one property is changed, the state is changed. So, the thermodynamic state of a system is completely specified by two independent intensive properties. Equilibrium is a state of balance. There are many types of equilibrium. Thermal equilibrium. When temperature is the same throughout the system. Mechanical equilibrium. When we have a uniform pressure. Phase equilibrium. When the mass of the two phases, for example ice and water, is in equilibrium. Chemical equilibrium. When no chemical reactions or chemical composition does not change with time. System is not in thermodynamic equilibrium unless the conditions of all types of equilibrium are satisfied. Any change that a system undergoes from one equilibrium state to another is known as a process. The series of states through which a system passes during a process is called path. When the system returns to its initial state at the end of the process, we say that it is a cycle. The equality of temperature between systems is known as thermal equilibrium. If two bodies are in thermal equilibrium with a third body, they are also in thermal equilibrium with each other. This is known as zeroth law of thermodynamics. Steady means that there is no change with time, while uniform means that there is no change with location over a specified region. There are many thermodynamic processes that are under constant properties. For example, constant pressure process is known as isobaric process. Constant temperature process is known as isothermal process. Constant volume process is known as isochoric process. Constant entropy process is known as isentropic process.